Pom has been learning about motion from watching us explore in class. He's noticed that anything with mass has inertia, or a resistance to change in motion. And so it makes sense that if you wanted to change the motion of something with lots of inertia, you would need a lot of force. But Pom has also noticed that when we change the force applied to something, it also changes the speed or direction. This is acceleration. Acceleration is a change in speed. So Pom thinks that these things must be related: force, mass, and acceleration. He would like to do an experiment to figure out how force, mass, and acceleration are related.
That's a good idea.
Okay, so Pom, if we're going to do this experiment, we need to decide how to represent each of our three variables.
Wait, what's a variable?
A variable is something that can vary, something that can change. A variable is something that can change in an experiment.
Okay, so for this experiment, we need to be able to change force, we need to be able to change mass and acceleration, right?
Right, and as we change those things, we can see how they interact together. We're trying to see how one variable might affect another variable.
Okay, so for this experiment, we need to be able to push or pull something in order to create a variable for force. We have to be able to change the mass, and we've got to be able to change acceleration.
Right.
Okay, so what if we took a card and we pushed that to represent force, and then, because force is a push or a pull.
Okay, and then maybe you have something accelerate into that, and that represents your acceleration.
Yeah, I could drop the string on it, and then to change the mass,
you can add more weights to the swing.
Yeah,
okay,
do that.
So we have our three variables. We have something pushing to represent force. We have something moving and accelerating to represent our acceleration. And we have something that we can use, our weights, to change the mass.
Yeah.
Now, how are we going to measure our variables?
Measure?
Yeah, if we do this whole experiment and don't write down any data, then how are we going to know how these variables relate to each other?
Okay, fair. What if we measure the push by measuring how far the card moves? That way.
Good idea. That would make force our dependent variable.
Our what?
Our dependent variable. A dependent variable depends on the other variables in your experiment. You don't get to control how that card moves. It depends on the other things you have, your acceleration and your mass. You're just seeing how far it moves and measuring it.
Okay, so the dependent variable is the one that I measure. Does that mean that the independent variable is the one I don't measure? I get to change that?
Yes, and then you...
Oh, no, hold on. I think I got that. So if I change the acceleration, like if I lift it up just a little bit compared to a lot, then that's independent because I chose to change that. And if I add more weight, then I'm changing the mass, and that's independent because I'm choosing to change that. But if I hit the card...
Yes, but there's
one
more thing
hold on.
you have
I think I got this. Let's go ahead and pause for just a minute because I think I understand. Let's do this experiment now, okay? I think we're good.
So in this experiment, we're going to use the push of a card to represent force, and we're going to use the swing of a string to represent acceleration, and the weight on the edge of the string to represent mass.
So we're putting our card at the edge. I'm going to lift up the string just a little bit so we have low acceleration and let it go. And it looks like we are at 4 centimeters. So we're going to write that down, 4 centimeters. And now I'm going to use my weight to increase the mass as one of my independent variables. And this time I'm going to lift up the string higher so that there's higher acceleration. So higher acceleration and higher mass. Here we go. Oh, yikes. Definitely messed that up. Let's try again. Okay, let's get this right. Maybe this time I'll increase the acceleration but not increase it quite as much. And let's see what we get. Okay, it looks like we were at about 24 centimeters. So we're gonna write that down on our data table, 24 centimeters. Yeah, that wasn't too hard. I think we have some good stuff to report here.
All right, so you did the experiment.
Yeah, and the card moved a lot the second time.
Great. So, which one increased the force then? Your acceleration or your mass?
Shoot, I don't know, because I changed them both.
Yeah, if you want to find out the relationship between your variables, you can only change one variable at a time. Otherwise, how do you know which variable was it that was causing that change?
I mean, I don't, because I changed them
And
both.
you have to do your experiment more than one time.
What?
Because what if you mess up? Then you'll go on thinking that your messed up data is true.
I did mess
The
up.
more you do an experiment, the less likely it is that it's messed up data.
That makes
because
sense.
you're doing it over and over.
Okay, I
So
get it.
the minimum needs to be at least 3 times. You've got to do
times.
each experiment at least 3
Okay,
times.
I got it.
More is better.
I got it. We can do it. We got this, okay? Yeah,
Okay,
settle down.
fine.
We're going to redo the experiment. It's going to be okay. All right, here we go. Okay, so we can't change both of the variables. So this means this data wasn't working. We got to pick one. Let's do acceleration. So we're not going to do mass this time. We'll pick acceleration. And we have to do it at least 3 times. So let's change our data table to fit at least 3 trials worth of data. So we've got 1, 2, 3 times for each one. All right, here we go. We're going to take off one of the weights that we had last time. So we've only got 1 weight. We're not going to change the mass this time. We are going to change the acceleration though. So we're going to lift it up. We're going to have a low acceleration, so we're not going to lift up the string very far so that it doesn't accelerate very much. And here we go. We are at about, I'm going to say 3.5 centimeters. 3.5 centimeters. But we have to do it again because we have to do more than once. Here we go. Oh, look, that was only 1.5 centimeters. 1.5 centimeters. And we have to do it 3 times. So let's reset. Low acceleration. And we are at 1.5 again. 1.5 centimeters. Okay. Now we're going to change our independent variable. I'm not going to add more mass. That was my mistake last time. This time I'm going to increase the acceleration, just the acceleration, not the mass. Let's reset. Higher acceleration. Okay, it looks like we went to 13 centimeters. We're going to write down 13 centimeters. Okay, we got to do it again because we can't just do it once. Reset, high acceleration. Okay, it looks like we are at 14 centimeters. Okay, so we're going to write down 14 centimeters. And we have to do it at least 3 times. So here is our 3rd time. High acceleration. Okay, it looks like we are at 11 centimeters this time. All right, now we have data that's much better than last time. We're only comparing one independent variable to one dependent variable. So it's easy to tell if those things have an interaction. But we have a lot of numbers here. We need to find a way to make these easier to look at. And the way we do that is we take the average of each set. And the way we find an average is you add your numbers together and divide by however many numbers you have. So we're going to add them together, and then we'll divide by 3 because there's 1, 2, 3 numbers for each acceleration. So let's go ahead and add them together. We've got 3.5 plus 1.5, which is 5, plus 1.5, which is 6.5 centimeters. Then we have 13 plus 14, which is 27, plus 11, which is 38 centimeters. And now we're going to divide them by 3. So we have 6.5, 6 divided by 3 is 2, 5 divided by 3 is 0.15, I think. So that averages to 2.2 centimeters. And then 38 divided by 2, and then 38 divided by 3, because we have 1, 2, 3 numbers here, is 30 divided by 3 is 10, 8 divided by 3 is 2.4, so that gives us 12.4 centimeters. Now we have numbers that represent each set of data, but these numbers are easy to compare. This is 2.2 centimeters, and remember, this represents force because it represents how much our card was pushed, and a push is a force, right? So this represents a force pushing 2.2 centimeters, and this represents a force pushing 12.4 centimeters. We can tell when there's low acceleration, we have low force, and when there's high acceleration, we have high force. This is part of Newton's second law, which shows the relationship between force and acceleration. If you increase force, it increases acceleration. For example, if I have Pom-Pom, if I apply a small force, he only accelerates a little bit. If I apply a big force, then he has a big acceleration. Force goes up, acceleration goes up. This is part of Newton's second law. The other part of Newton's second law is that mass is also related to force. So how would you change this swinging experiment to incorporate mass instead of acceleration? How would you do that to find what the relationship is between mass and force?